All right, y'all, I'll be recording this video for support 3.7, and it deals with a lot of graphing using various styles, okay? So you want to pay attention to this. So I'm going to share the MATLAB screen where I'm actually doing the homework, okay? So notice number one says use the intercepts to graph the equation. So intercepts, so let me write this problem down for number one. X minus 5 equals y. So intercepts means you need 1 point on the x-axis when you're done, which will be the x-intercept, and 1 point on the y-axis, which will be the y-intercept. So I'm going to go to my notes so y'all can watch me work this. So basically, when you set up your x and y table for this, the x has to be 0 for the first point, the y has to be 0 for the second point. So first you put a 0 in for the x, so 0 minus 5 equals y, so you get negative 5 equals y. So y would be negative 5. Then you put a 0 in for the y, so you get x minus 5 equals 0. So on that one, you would add 5 to solve for the x, and you get x equals 5. So the second point would be 5, 0. So you have an x-intercept of 0, negative 5, a y-intercept, an x-intercept of 5, 0, and my y-intercept of 0, negative 5. Okay? So I'm going to go graph these 2 points and be done with this. So let's go back to the MATLAB. All right, so here we go. We got to click to enlarge the graph. That's got an X in it, so it's going to be a straight line. So I had my first point was 0, negative 5. So that's my y-intercept. I'm on the y-axis. And then my second point was 5, 0, which is my x-intercept. All right, so I'm done. So I would save that and check my answer. So let's move on to the next question, number 2. Same thing, use intercepts to graph the equation. So number 2 has x plus 2y equals 4. So let's go to the screen and watch that be worked. All right, so x plus 2y equals 4. Once again, I'm going to do an x and y table with the x being 0 and the y being 0. So that gives me my y-intercept and an x-intercept. So first put a 0 in for x. So 0 plus 2y equals 4. That's just going to give you 2y equals 4 because anything added to 0 is itself. And then to solve that, you would divide by 2 so that y equals a positive 2. Now, we put a 0 in for the y, solve it for the x. So that'll be x plus 2 times 0 equals 4. All right, so x plus 2 times 0, you multiply, that's 0. That's going to equal 4. And x plus 0 is x, so this final answer is x equals 4. So I got my 2 points, x-intercept, y-intercept, so let's go graph those. Going back to MATLAB. All right, so we're going to click to enlarge the graph. I'm going to plot the line tool again because that's just x's and y's. So we want to go to 0, 2 for my y-intercept, and then come down here and go to 4, 0, which is what we got for our x-intercept. Save that and check your answer. But I want y'all to notice, you got to have a point on the y-axis and a point on the x-axis when it wants you to use the intercepts, okay? Any other point might give you that line, but that's not what they're asking for, so that's why they mark you wrong. All right, same thing on this number 3. 5x plus 3y equals 15. Graph by intercepts, which means we will be setting up an x and y table again and making the x 0 for the first point, y 0 for the second point. So let's put a 0 in for the x. And if you notice, anytime you put a 0 in for the variable, if it's got a number in front of it, that's always going to give you 0. 5 times 0 is 0. So basically, this is 3y equals 15, because that's 0. And then to solve that, you divide by 3, so that y equals 5. Now, I put a 0 in for the y and get my x. So 5x plus 3 times 0 equals 15. Well, 3 times 0 is 0, so that's gone. So you get a 5x equals 15 divided by 5, and x equals 3. That's the reason they'd like you to use the intercepts, because it's easy to multiply these and get rid of them when you got zeros there. So we like y'all to learn this method. But remember, it only works for straight lines, okay? All right, so let's click this. We're going to have a straight line again. So we're going to draw the straight line tool. I had 0, 5. So there's 5 on the y-axis. And then 3, 0 on the x-axis. I'm on each axis now, so I'm going to save that. And then I would check my answer. And then move on to the next question. So what's this, number 4? Find intercepts and then graph. So same thing, 3y equals -6 plus 2x. So let's go to the screen and work that one. All right, so intercepts means I'm going to do the x and the y with a 0 and a 0. So put a 0 in for the x. I got 3y equals -6 plus 2 times 0. Well, y'all, the 2 times 0 is gone, so 3y equals -6. To finish that, we divide by 3, and y equals a -2. So my first point, 0, -2. Now put a 0 in for the y and get that x. So that'll be 3 times 0 equals -6 plus 2x. Well, this side's going to stay 0, and I'm going to leave the 0 here for a second because I need a placeholder over here. Since that equals 0, I need a placeholder. So now we want to get the x by itself, so add 6 to both sides. So 6 equals 2x. Divide by 2, so that 3 equals 1x. So here's my 3. So now my points are 0, -2, 3, 0. So we're going to go graph those on MATLAB. All right, so I'm going to click to enlarge my graph. Use my line tool again. Let me get over there. There's my line tool. So I had a 0, -2, which is right there. And then I had a 3, 0, which is right there. Save, check, and move on to the next question. So this next one will be number 5. Graph the equation using the slope and y-intercept. So I got y equals 9/7 x plus 2. So y'all, let me tell you, I don't have to go to the pad on this because I can show you with my screen right here. I'm pointing to the 2 right now. This is in y equals mx plus b form. B is always the y-intercept, so that means this 2 at the end is the y-intercept, and the y-intercept always has the point 0, 2. Now, the 9/7 is where the m is, and that's the slope. The top number is the change in the y. The bottom number is the change in the x's. So since the top number is positive, this would move 9 up in the y direction from the 2. Then you would move right 7 in the x direction for the bottom number. So the top changes the y's, the bottom changes the x's. Now if you have a negative, you're going to keep the negative on top with the y, so that the y can either go up or down. The bottom will always be positive, so we're always going to move the bottom to the right. Okay, graphs move left to right. So any negatives will go up top. So on this problem, I know that my y-intercept is 0, 2. So watch this. I'm going to click to enlarge my graph. Well, it's being slow now, right? All right, there's my graph finally. So it's going to be a line tool, okay? So since the y-intercept is 2, I go to the y-axis and I start at 2. Now notice this graph goes by 2's for every point, okay? Now, the top number is where I move on the y-axis, and since that 9 is positive, I start from where the 2 is and go up 9. So if you have 2 and you add 9, that's going to put you up here at 11. So look here on the screen, I'm showing 0, 11 in the top right corner. But now I got to move my x's. So the bottom number is a positive 7. So from where you are at now at that 11, you're going to move right 7 units. So that my point is now 7, 11, and I'll click it. Now check this out. If you went up 7 if you went up 9 again and over 7, you're still on that line. No matter where you are on this line, if you go up 9 and over 7, you're going to be on the line, okay? That's how the slope gets you from one point to another on this line. So top number, I went up and down. That was positive, so I went up. Bottom number is always positive, so we went right. Don't worry, we got more of these, and you're going to get the idea. Although some of these we might have to solve. Ooh, my math lab's running slow, y'all. Must be my internet. So maybe I'll quit checking them since it's being so slow on checking them. And I'll just show y'all how to actually do them. Because look, I'm having a lot of lag. So once I graph it and show you how to do it, I'm going to move on to the next one without having to wait on this thing to load every time. So we should be getting on number 6 now, if it ever loads. All right, there we go. I'm getting something. It's popping a 6 up here, so now it's got to change this bottom. All right, so this one has f of x equals negative 6 over 5x minus 6. Remember, f of x just means y. So they'll either use a y there or f of x, but they mean the same thing, okay? My y-intercept is still going to be that negative 6. So when I click my graph over here to start graphing it, I'm going to start at that negative 6. It's going to be slow loading every little window for me, it looks like, but that's all right. We got time. That keeps me slower for y'all, right? Because I do have a tendency probably to go a little fast at times. Not tonight, right? Woo, y'all, look at that, it's spinning. There we go, there's the graph. So I'm going to get the line tool. Since the y-intercept is negative 6, I'm going to start at negative 6 on the y-axis. So this is right there. It's going by 2's again. Now this is a negative 6 over 5. So the negative will stay up top with the 6, and the 5 on bottom will be positive. Only one of them can be negative, and we're always going to keep it on the top. So from that negative 6, go down 6 would have put you at a negative 12 right here. And then remember, since the top was negative, the bottom is always going to be positive. So from 12 right here, that negative 12, we go right 5. Oh, come on, move. All right, so then I'm at 5, negative 12 is actually my point, okay? So click that. So remember, I went down 6, right 5. I started at my y-intercept of negative 6. So see, they're giving you everything when it's solved. You ain't even got to do no math. You just plot 2 points and you're done. All right, so remember, I'm going to the next one because I don't want to waste time on, we know. All right, number 7, 2x minus 5y equals 10 using the slope intercept. So let me show you what you got to do on that. I'm going to have to solve this because if they want me to use slope intercept, I got to know what I want this in y equals mx plus b form. That way I know my slope and I'll know my y-intercept. So we got to get the y by itself. So let's subtract 2x from both sides. So watch this. The negative 5y comes down. This side, those x's canceled. Now over here, you got a 10 and a negative 2x. Since they're not like terms, put them in order that you need them. Put the negative 2x plus the 10 so that we got the x first and then the y-intercept, okay? Now, you got to divide everybody by negative 5. So that cancels, giving me my y. Negative divided by negative makes that a positive 2/5 x. And then a positive 10 divided by negative 5 makes that a negative 2. So my y-intercept is going to be 0, negative 2. That's where I'm going to start at on the y-axis. My slope, which is my m, is 2 over 5. So from this point, negative 2, I'm going to go up 2 and then right 5. So these are both positive, up and right when they're both positive, okay? So we can go graph that now. So see, the hardest they're going to get is you might have to solve it for that y. So I'm going to click on this and be the second. Oh, it's quicker now. There's my line. So we said we're starting at negative 2. So negative 2 is right there. And then I said I would go up 2 and right 5. So up 2, right 5. That's using my slope of positive 2/5 that we came up with. So see, if you get any signs wrong, your line won't go up, it might go down, which would be wrong. You gotta watch these signs when you're moving stuff from side to side and when you're dividing by negative numbers on those, okay? All right, so next I'm gonna go to number 8. It's gonna tell me, yeah, blah, blah. All right, y'all, number 8. Graph the following equation and if possible, determine the slope. All right, anytime you got x equals any number, that's going to be a vertical line, and the slope of any vertical line is undefined, okay? So you don't need to make no graphs or anything or no tables to do this. All you got to do is click on your graph. So watch this. When they say x equals 4, that means every x has to be 4. So you go over here to the x-axis at 4 and you click it. And then you can either go up or down and click it again. But you want this to be a vertical line so that any of these points on here, when you move them on that straight up vertical line, notice the first number is always 4. Always 4 when I go in that vertical line. See, my y has changed, but my x is always 4, okay? And if I move this one down here, if you notice in the corner, it's changing 4, negative 3, 4, negative 4, 4, negative 5, and so on. As long as I'm on that line right there, my x value will always be 4. It don't matter what the y values are, the x is always 4. Those vertical lines, and like I said, they always have an undefined slope. So the slope of an undefined line would be b. The slope is not defined. So vertical lines are undefined because they don't move left or right. They're just straight up and down, and you can't have that. You got to move left or right, like I said, for your time, okay? All right, so let's get to the next one. Oh, I checked that, and I wasn't supposed to. All right, now here's y equals 5. Same thing, but when you got y equals 5, you'll have a horizontal line going left to right. And horizontal lines have a 0 slope. When you're walking on your floor, it's flat, it's horizontal, it has a 0 slope. When you go up a mountain, that's a positive slope. When you go downhill, that's a negative slope, okay? So watch this. Just like I did with the x's, I'm going to do this one to where all the y values are always 5. So that's going to be horizontal. So this one, since y equals 5, I go find 5 on the y-axis and click that. And then I go left or right. See how the y values are always 5, but the x's are changing in that point in the corner? No matter where I go, that y value is 5 because I'm on a horizontal line. So we would check that. And then, like I said on this one, our slope is definitely 0. Horizontal lines always have a 0 slope. Vertical lines always are undefined slopes, okay? So look at that, y'all. We're on number 10 now. Y equals -4. So I ain't got to go nowhere but click my graph, right? They're giving me everything I need. Click our line tool. Y equals -4. Go to -4 on the y-axis. Click that. And then go left or right. So I went right last time. I'll go left this time. But notice those points are always -4 something. -4. -5, -4. -6, -4. -7, -4. My y value is always -4. Okay? So save that. And they're going to want me to do the slope again because we know what the slope is, right? It's horizontal. So the slope is 0. All right, let's see if they get moving, y'all. They're in number 11 here. X equals -3. So remember, X's are vertical lines. So you got to go find one of these that has a vertical line at -3 on the x-axis. The very first one, every point on that line has an x value of -3. Every point on this one has a y value of 3. Every point on this one has a y value of -3. Every point on this one has an x value of 3. So we wanted x equals -3. So we would click A and move on. Okay, so you got to get used to when you got a y equals a number and an x equals number are going to be special lines, okay? All right, so this is what, number 12. So y is greater than 6x. They want me to graph that. So I'm going to show you by hand what I would do to that. So first of all, I would make up a table and get me an x and a y. So I'm going to use the x value of 0 and an x value of 1 to solve this, okay? So they're not telling me to use intercepts or nothing. You could have used intercepts and made both of them 0, but you didn't have to. So watch this. If you put a 0 in for the x, well, that's just y greater than 0, so you get a 0 for that y. If you put a 1 in for the x, you just get y greater than 6, so you get a 6 for that one. So now I got my 2 points. I'm going to graph this. Now, since it's a greater than or a less than, remember, greater than or less than, you shade with a dotted line. If you got equals under those, you would use a solid line. Now, greater than like this, or greater than or equal, you shade above when you shade. And if it's less than or less than or equal, you shade below. So I plot my points, and then I use this data to plot my lines, okay? So here we go. Watch this. We're going to go back to MATLAB. So, let me go. Y'all hang on. I'm going to go right back to that again. I want to graph this because they're giving me the pictures. They're not wanting me to graph it by hand. So let me graph this real quick, and then we'll pick the right picture. So here's X and Y. So I got to go up to 6 at least on this. So 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, -5, -6, -5, -6. All right, so 0, 0 is right here in the middle. So I plot that point. And then 1, 6, you go right 1 and up 6. So there's that point. So now, since there's no equals and it's just greater than, I would draw a dotted line between these points like this. So there's my dotted line, and it's greater than, so greater than with a shade above. So you come to what's above on the line, and you shade all that. So I'm looking for the picture that has this diagonal line like we got dotted, shaded to the left. So let's go to our pictures. All right, there we go. Look, shaded to the left and a dotted line. That one's shaded to the right. That one's got the right line, but it's shaded right again. And then that one's shaded left, but the line is diagonally to the right. Ours was going uphill left to right, okay? So we picked A, and then we'll check that real quick. And next question. We're getting on number 13, y'all. So we're getting there. It's not bad. It's just trying to bring back memories. So this says y less than or equal to x minus 3. And once again, they just want me to pick the picture. So I'm going to draw the graph real quick, and then we'll pick our picture. So once again, I'm going to set up an x and y table. I'm going to use 0. You know, I might use 3 because watch this. If I put a 0 in, I get -3. So I can put that -3 right there, right? 0 minus 3 is -3. Now watch this. When I put a 3 into that, that'll be 3 minus 3. Well, y'all, 3 minus 3 is 0. So I get a 0 there. So that was that little less than or equal thing. All right, so 0, -3, 3, 0 is going to be our points. So 5, 5, -5, -5, that's x's, and that's y's. So my first point was 0, -3. So remember, that's -3 on the y-axis. This point is 3, 0. So 3, 0 is on the x-axis. And you see, the way I did it, it came out to being the y-intercept and the x-intercept, right? All right. The line, this one has the equals under it. So remember, I said if it has the equals, it's going to be a solid line. Less than, shades below. So we're looking for the picture with the line like we got it. So let's go back. And to me, let's see, that looks like a solid line with my angle. This one's dotted. This one's solid, but they shaded above, and then that one's dotted. So we wanted solid line, shade down to the right. Check that answer, and now comes 14. Right, 14 is 4x plus y is less than 4. So the thing on it is being able to graph them, right? Being able to graph it. So you just got to come up with 2 points, okay? So you can do the 0 intercept method on this, right? When they're not solved for the y, a lot of times this is the easiest method is just to use zeros because you don't have to solve it for the y and worry about signs and stuff, okay? That's why we were showing you the intercept method. A lot of times it's the easiest way to do this when they're not solved and you got x's and y's on the both sides, on the same side. So watch, I'll use a 0. 4 times 0 plus y is going to give me the 4. Well, that's 4 times 0 is gone, so y is equal to 4 for that one. So that wasn't bad. Now put a 0 in for the y, so 4x plus 0 is going to be 4. Well, 4x plus 0 is 4x less than 4, but then you would what? Divide by 4 so that this gives me x less than 1. So remember, I'm solving this, but you would treat these like equal signs. What you do to one side, when you divide, you did to the other. Okay, this I was just adding like terms and got my 4x. And I'm just working these like I would if that was an equal sign, just to get my numbers. All right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I don't even have to draw this part really because all my numbers are positive. Watch this. 0, 4 is 0, 4. Once again, I got x and y intercepts, right? So here's 1, 0 will be on the x-axis at 1. That is less than right here, right? Since the y is on the left and it's less than, it's like a less than. So there's no equals, so that'll be a dotted line. And then we would shade below because it is less than. So that would be all of that shaded, okay? And remember, my line is dotted. So I would go back to my screen. All right, so let's see. Solid line, no. Solid line, no. That's dotted, but they shaded to the right. That's dotted, and they shaded to the left. So we would pick our B. And then move on to the last question, y'all, number 15. And hopefully this is bringing back graphing memories, okay? 2x minus 5y is greater than 10. So I'm going to go back to the screen and graph that real quick and show you that on that one, since the x and y are on the same side, once again, I'm going to use zeros and solve it by the intercepts. That's the easiest way. Put a 0 in for the x. 2 times 0 minus 5y is going to give me 10. Well, that's gone. So negative 5y is going to give me 10. Divide by negative 5. Remember, they're multiplying, so you got to divide so that gives you 1y. And then 10 divided by negative 5 is a negative 2. All right, now put the 0 in for the y and get an x. So 2x minus 5 times 0 is going to give me 10. Well, 5 times 0 is gone, so 2x is going to give me 10. What are you going to do? Divide by 2, and x is going to give me a 5. So I got my 2 points. I'm going to come down and graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's my y. That's my x. 1, 2, 3, 4, 5. I'll make this an all because I had a negative number up there. All right, 0, negative 2, starting at 0, you go down to negative 2. The y-axis is negative 2. The x-axis, it said puts that point at 5. So go to 5 on the x-axis. Put your point. Now, the trick on this one, since this 5 is negative in front of the y on this side, in the long run, remember, we would have to make the y negative. So anytime the y is negative, you got to reverse the inequality. So just remember, if you start with a negative y, you're going to make that a less than. So look, there's no equals, so it's a dotted line again, going like that. And we had to flip it because y was negative and make it less than, so we would shade all that below. Had that been a positive 5, I would have left it the same, and I would have shaded above that line, okay? So let's go, what they give me on this in pictures again. So we didn't have to graph none of these like you did in the real class, college algebra. So mine was dotted and below, so I'll go B on that, y'all, and be done. Okay, so if the y is negative, you got to reverse it. If the y is positive, leave it alone. Now, I didn't have to solve it for the y. We just know that rule that if we did solve that for the y, we would have had to reverse it because the y was negative, okay? Woo, y'all, that was a good one there. So that was what, 3.7 college algebra support. So y'all work on that graphing because we'll be graphing all year, okay? So we're going to stop the recording, and I'll see y'all in class or online. Have a good one.